Hi, let's do some more revision. And today we're going to look at the net present value. I'm your tutor, and this is another in the TV Barbados series. Now, the net present value, what we call NPV, seeks to calculate the expected gain or loss on a project by simply discounting its expected future inflows and outflows to their present values using some selected rate of return. The idea is that $100 today is not the same as $100 in the future because the future is uncertain, but we are sure about today. So what we're trying to do is to convert the future into the present. All right, hence the term net present value. Now, you can work out the net present value by simply finding, by summing all of the discounted cash flows over the time period, in other words, from the investment down to the last day of the project. You could sum all the discounted net cash flows, and that should give you your net present value. All right. I've shown you the mathematical formula, but you're probably unlikely to use it. Another way, of course, is that in other words, the examiner doesn't give you all the different breakdown for the cash flows. You can use the investment minus the annual cash flow if it's an annuity, right? The annual cash flow times the present value annuity factor, right? And you will still get the net present value. All right, so let's use a table to probably help us to work out the net present value if you're given, obviously, the series of cash flows over the different years. So therefore, first what you would do is to then determine what are your annual cash flows, all right? Because obviously in a case like this, they may vary. And if they vary, you use the table, right? So in this instance then, this table, remember, is just a theoretical concept. It probably won't look like this in the exam. But basically what we do, we have a column for the outflows and we have a column for the inflows. And we're basically trying to find the net difference, right? In other words, what's the difference between the outflows and the inflows? You may see a column here marked tax, and that's because tax is not normally in the question, but if tax was given, you will have to take it away. So it says apply the tax if it is part of the process. Otherwise, look at the list of inflows and the list of outflows, just subtract from each other, and you will get the net cash flow. Now, once you have the net cash flow, then the second thing to do is to apply the discount rate, right, which is known as the cost of capital. You're going to apply that rate in its discounted form. So normally the examiner will give you a table to work it out. Remember, it's 1 over 1 plus I raised to t, wherever specific year that is. So 1 plus I to the 0, then you got to add on 1 plus I to the 1 all the way down till you get down to t. So instead of getting through all that trouble, you're given a table with these things already worked out. All right, so all you're left to do is to multiply your net cash flows, right, which I'm calling E, by the discounted, by the present value interest factor, right, based on the rate of that cost of capital. So R represents your cost of capital. So whatever number is given to you, you use, and you will multiply out to get the discounted cash flows. So remember, anything raised to the power of 0 is 1. So that's why you have 1 here. That's not going to change. So the investment in year 0 multiplied by 1 will still be the investment. is the other things that will change. All right, so this would be whatever interest rate you're using to the 1, and that would be itself. So that would mean that you have to work with that all the way down to get out to t. All right, now once you've done all that, you're going to sum all of these discounted cash flows. So over here in this column, starting from the investment all the way down, you're going to add all those together, and that's going to give you the net present value. As simple as that. All right. Now, I know you're probably wondering, so what do we need to know the net present value anyhow? All right. So the net present value is a technique that you're going to use to compare the returns on projects. So in other words, you have a series of projects to choose from. You're not sure which one you want to go with, so you need some information. So the net present value will give you some information to help you to decide which project to choose. All right. So what's the advantage of using the net present value? Well, one advantage would be that it's going to give you a clear decision rule. It says if the NPV is positive, you should accept the project, and if it's negative, you should reject the project. It also uses all of the information. So whenever there are inflows or outflows during the time of existence, so in other words, however long this project is, at which point you put in money or take out money, right? It's going to use all that information to come up with an answer for you. Therefore, you're going to give you an exact measure in dollars as to whether this project will gain you a return or cause you to lose your return. All right. And what else does it do? It takes into consideration the one thing that I told you earlier, which is that the value of money changes over time. And so it takes that into consideration by simply discounting the expected values that you have, right? And bring them into the present. And therefore, the thing about it is that you can, so that you're supposed to determine that discount rate. So you can plug in different discount rates and get an idea as to what you're looking for. So remember how it goes. The riskier the project, right, the higher the discount rate you will use, and the least risky the project, the lower the discount rate you will use. That's the general concept. All right. What disadvantages then does this net present value present? Well, it does depend heavily on you making proper estimates of the inflows and the outflows. So if you estimate them incorrectly, then everything else you're going to get is rubbish. Remember how it works, right? Garbage in, garbage out. All right. Also, the net present value is affected by a certain peculiarity in the timing of the inflows and outflows. In other words, if you get large outflows at the beginning and a small amount at the end, it's going to give you a slightly different concept if that was turned around. In other words, if it's getting low returns at the beginning and high returns at the end. So you may actually end up discarding a project that you should have kept. All right. In any case, if the project's got different time periods, you might have a little issue, especially if the time periods are far apart. If one is 5 years, the next one is 8 years or 10 years. It might be a little difficult in your thing. Another thing it does, though, is that it excludes non-financial data, which, by the way, as you would know, is key to helping you to make a decision. You know, how is it going to impact your staff, your customers, the environment? Is there any political ramifications, etc.? All right. Legal fees, whatever involved in there, legal complications, sorry. And of course, as I said earlier, once the time periods are different, you may have a little challenge. But other than that, it's a useful parameter because it tells you upfront. If it's positive, you should think about picking it. If it's negative, you could just ignore it. All right. So let's test out what we just looked at and see how it works. So we have this project is $90,000. It can be scrapped for $15,000 after 5 years. And so we have the expected inflows here, 38, 35, 32, all the way down. there's a tax on these inflows, however, of 20%, and the cost of the capital is going to be 10%. So all we got to do is just plug, right? Because remember, it's that easy. So you take the first part that says put in the thing and find out what's the net cash flow, right? So we put in, because we're given the annual flows. So we put in the annual flows, we got them 38, 35, 32, and we know there's a tax on each flow, so we tax that, and we get that the net cash flow is given here 28, 28 all the way down. Remember, the investment won't change because that's multiplied by 1 in case the investment is the investment, right? So now secondly, we apply the discount rate to this. So remember that discount rate was 10%, right? That's the cost of the capital, 10%. So let's apply that. So we go to the table, we find the information, we got the 10%, right? Which is 0.9, 0.8, 0.7, 0.6, whatever, right? Just make sure you use the table. Notice that you have to put in the scrap value, however, because that is, you can actually sell it for that. So that's an inflow, and you would tax that as well. All right, good. So then we come to the third one, which is to add up all of these discounted figures, and that should give us the net present value. Just simple like that. All right, so let's add them all up. All right, and we get that when we add them all up, we have a positive return of 16,771. So which means that, if you was choosing, this would be a project that you can consider. All right, so that is all there is to the net present value. So you just got to keep practicing, and until next time, 8-9.